This is the ship MF Hydra. It is currently the only ship powered by liquefied hydrogen. It's a passenger ferry operated in Norway, and it makes absolutely no sense to run this ship on hydrogen. And I'm gonna explain in this video why. Before going into this specific ship, I want to more generally explain what role hydrogen could play in cleaning up shipping. Obviously, ships cause a lot of CO2 emissions, and we need solutions for that. For small to medium-sized ships, that is very often passenger ships operating in coastal areas, it's often a very good solution to power them with batteries. That can already reduce emissions today, even if you don't have a perfectly decarbonized grid, because batteries are very efficient. And it also avoids air pollution, which is particularly important if they operate in populated areas. On the other end, you have very large container ships, and for those, hydrogen is probably not a very good solution because they need more energy than you can plausibly provide with hydrogen. And there are two chemicals that are discussed as the most likely future fuels for large container ships, and those are methanol and ammonia. They are currently produced from fossil fuels, but you could make these chemicals from green hydrogen, and so this would also be a way of using hydrogen to power these ships, but it would be an indirect way. Hydrogen itself could maybe serve as a solution for medium-sized ships, but even there, it's not entirely clear if there even is a market between those two. It will come under pressure from batteries that will obviously get better, and there will be larger battery-powered ships in the future. And if you already have these other clean fuels for the larger ships, there may not be much space in between where hydrogen could play a role. But if hydrogen would play a role, then the most likely place would be in this in-between sector of medium-sized ships. Hydrogen has some important properties that need to be considered when talking about using it as a fuel. Hydrogen has a very high energy density per weight, which means you don't have to transport a lot of weight for your fuel, which is a problem with batteries, because if you want to power a very large ship, the batteries just become too heavy. On the other hand, hydrogen has a very low energy density per volume, which means if you want to transport a meaningful amount of fuel, you need a lot of space for that. In order to tackle this problem, if you want to use hydrogen as a fuel, you usually would either compress or liquefy it. Either you put it under pressure, then it needs a little bit less space, or you cool it down to turn it into a liquid, and then you have a denser fuel, but it's still not as dense as other types of fuels. Liquefying hydrogen is not easy. You need to cool it down to very, very low temperatures, around minus 250 degrees Celsius or more than minus 400 degrees Fahrenheit, to cool hydrogen down so it becomes a liquid. This is a ship. It's not powered by hydrogen, and it's also not powered by any other clean fuel, which you can also obviously see because there's smoke coming out of its exhaust stack. But its operator, the shipping company DFDS, has investigated whether they could run this ship on hydrogen. And they have published a feasibility study. And I'm mentioning this here because in this feasibility study, DFDS has looked very closely at the different options to transport hydrogen fuel. There's a chapter in there about liquefied hydrogen, which is kind of discouraging. They list a number of problems with liquefied hydrogen, and just to emphasize, these are problems in addition to the other problems you already have with hydrogen. They say it's energy intensive. The liquefaction, not just the hydrogen production, but also liquefying it, is an additional step that is very energy intensive. It requires very complex infrastructure to deal with this cool liquid gas. It's not very flexible. You have very long startup times for the plant that turns hydrogen into a liquid. They mention that it can take up to a week to start up such a plant. They mention thermal stress for the materials, and they also mention something called a boil-off effect. The latter one I want to talk a bit more about. Whenever you cool down a gas to very low temperatures to liquefy it, you have this so-called boil-off effect. Some of your liquefied substance will turn into a gas again, and that is just due to the fact that there's always some temperature exchange with the environment. Some of your cooled down gas will warm up again, and then it becomes a gas again. This is not just a problem that you're losing some of your gas, or you may have to maybe burn it off or re-liquefy it, which takes additional energy. It can also be a problem of emissions. And this is not very well known, but hydrogen itself is a greenhouse gas. It's an indirect greenhouse gas. It impacts how methane is decomposed in the atmosphere. And this is relatively recent research that this is based on. It was known for a while that this is happening, but only in recent years some new studies came out that have analyzed this effect in much more detail and came to the conclusion that this indirect greenhouse effect from hydrogen in the atmosphere is much bigger than previously thought. There's one study that received a lot of attention that I have mentioned here, and I will also put a link to that in the description. Going back to that ferry in Norway. When you want to power a ferry with liquefied hydrogen, well, then obviously you need liquefied hydrogen. So where do you get that from? That actually turns out to be difficult because there's currently no plant in Norway that can produce liquefied hydrogen, as this is, as I explained, a relatively complicated process, and there are not many hydrogen liquefaction plants, and there is none in Norway. In order to source the liquefied hydrogen for the ferry operator gets its hydrogen from a plant in Germany that's operated by the company Linde. That may sound surprising, particularly if you follow the discussion around hydrogen. Making green hydrogen requires a lot of clean energy. If you want to make green hydrogen, you would do it in a place where you have a lot of clean energy, and particularly where you have a lot of cheap clean energy, because otherwise the economics of your plant don't work out. Most of the electricity in Norway is already produced by hydropower, which is generally considered a relatively clean source of electricity. Germany, on the other hand, still has a lot of coal power. It's getting better. We get more renewable energy, but it's still, Germany has a relatively emission-intensive electricity grid. This picture here actually shows a coal power plant which is located very close to that hydrogen liquefaction plant that Linde is operating. You may also wonder, how do they actually get liquefied hydrogen from Germany to Norway? It's actually pretty hard to transport hydrogen. There's not really any good options for it, and when you have liquefied hydrogen, it gets even harder. And it turns out, they're actually doing that by truck. You have these hydrogen trailer cars that can transport liquefied hydrogen. Remember that boil-off effect? Maybe not the best idea, but that's what's happening. The liquefaction plant in Germany is located in a chemical facility in a place called Leuna. The ferry is in a municipality called Hjelmeland. If you want to transport it there, it's at least 1,300 kilometers. If you take the land route, it's even longer. I don't know what exactly the route this transport is taking. If you take a ferry, it's a bit shorter. But in any case, it's quite a long way for such a transport. This adds additional emissions because these hydrogen trailer cars also need a fuel. I want to talk a bit more about this plant in Leuna. Leuna is a big chemical site. It's one of the biggest chemical industry clusters in Germany. And this is also where they operate this liquefaction plant. This plant is also supplying hydrogen to many of the hydrogen filling stations in Germany for hydrogen-powered cars. Last year that got quite a bit of media attention because there was actually an explosion at this liquefaction plant. There was a leak at one of these hydrogen trailer cars that eventually led to an explosion. In the following months, many of the hydrogen filling stations in Germany actually had to reduce their operations or even completely shut down. This plant in Leuna is primarily producing hydrogen from fossil gas. What you can see here is not just a liquefaction plant, but also a so-called steam methane reformer, which is the common way to produce hydrogen today for industrial uses. It's, for example, used to produce fertilizers or other chemicals. It is used in refineries, and it is used to power the few hydrogen-powered cars that are out there. Almost all of that hydrogen comes from fossil gas. And that is actually a very emission-intensive process. It's not a climate solution, it's actually a climate problem, and it's something that needs to be cleaned up as well. Up until quite recently, Linde actually had plans to increase the production of hydrogen from fossil gas in Leuna. They had plans to build a new steam methane reformer, so another plant to make hydrogen from fossil gas, which would have increased emissions even more. In 2021, however, they announced that they would no longer pursue these plans. They would not build a new steam reformer. And instead, they would build an electrolyzer, which is a facility that can produce hydrogen from water by using electricity. Originally, they announced that this electrolyzer would start production in 2022. Shortly after that, Linde announced their partnership with the ferry operator Norway in Norway and announced that they would supply liquefied hydrogen from this electrolyzer to this ferry in Norway. However, that electrolyzer did not start producing in 2022. It also didn't start producing in 2023 or 2024. What you can see here is a media article by a German television station. They figured out, A, this electrolyzer isn't running, B, Linde doesn't want to comment on it. They also figured out the company that is supplying this electrolyzer. They actually had mentioned that this project was delayed in their company report. This is a company called ITM Power. They are from the UK. In their annual report in 2022, they mention, unfortunately, delivery of this project has been delayed due to a number of factors, including supply chain constraints, changes to Leuna site requirements, and both manufacturing and testing delays. So this electrolyzer did not start producing in 2022. Now you may wonder, is this electrolyzer producing anything yet? It's now 2025, a couple of years later. I don't really know. Linde also hasn't answered to me. I've also asked Norway. They have answered a few of my questions, but they have not said anything about where their hydrogen is actually produced. The chemical site in Leuna informed me that the electrolyzer will start producing during 2025. It was not entirely clear whether it is already producing anything, but we can definitely conclude that it was not producing anything before 2025. Of course, projects like this often receive public subsidies. The electrolyzer by Linde received subsidies in Germany, and Norway's ferry received subsidies in Norway. To be clear, I don't think there's anything wrong with subsidies for cleantech projects. But when you pay subsidies, and in the case of this electrolyzer, it received around 12 million euro, wouldn't you actually want to know if it actually works? I asked the Ministry of Saxony-Anhalt, which is responsible for the subsidies and which is the Ministry of Economics in the area where Leuna is located. They told me that they wouldn't answer my questions and I should ask Linde if I want to know anything about the plant's operations. I also contacted the Norwegian Public Road Authority. They told me that the MF Hydra is operating on green hydrogen, and in a later email they told me that the hydrogen is produced at Linde Gas in Leuna. And from what I explained to you, it is very obvious that one of these statements cannot be true. And they didn't seem very interested in that. And that's what I find quite remarkable about this whole thing, that apparently the funders don't seem to be very interested in having a close look what they're actually funding there. This ferry has been operating since 2023, where this electrolyzer definitely was not running yet. So the question becomes, where's that hydrogen produced that they use as a fuel? I don't have an answer to this question. Nobody I've asked wanted to answer this question. I guess the ferry operator will know, Linde will know. I couldn't figure it out. Putting aside all these issues and whether it makes sense to transport hydrogen over such long distances and where it actually comes from, there's an even bigger question, and that is why? Why would you want to power a ferry with liquefied hydrogen? In case that's not obvious, if you can run something on a battery, that's a lot more efficient than using hydrogen. If you convert electricity into hydrogen, you convert it into another energy carrier, that always means you have losses involved. And then you convert that hydrogen back into electricity in a fuel cell, which means additional losses. And even more so, if you use liquefied hydrogen, you have 2 more steps that add even more losses. Whenever you could run a ferry on batteries, there isn't really any good reason to use hydrogen, let alone liquefied hydrogen. The MF Hydra operates on this route. You can see this triangle here. The longer legs of this triangle are around 5 kilometers long. And that is very well within a range that battery-powered ferries can cover. For example, this is the MF Ampere, and it's operated by Norway, which is the same company that operates this hydrogen ferry. It has been in operation since 2015, and it covers 7 kilometers. It's a bit smaller, but only slightly. This is another ferry in Norway. It is the Bastø Electric, and it is covering both a longer distance and transports more passengers than this hydrogen-based ferry. There are already passenger ferries that cover larger distances, that transport more passengers, and that are powered by batteries, and they are more efficient. Very recently, another battery-powered ship, the China Zorilla, was launched in South America. And this ship brings battery-powered ferries to a whole new level. It transports more than 2,000 passengers, and it will cover a distance of around 50 kilometers. And this already makes it competitive to many routes where you might have considered hydrogen in the past. I had already almost finished this video when I received another email from Norlet, the ferry operator. First of all, they confirmed what I already believed, that there's no reason that the route the MF Hydra is serving could not run on batteries. Norlet essentially argued that this was a way to test this technology so it could later be applied in other places where electrification via batteries was not an option. I am not convinced by this. First of all, I feel if you look at the marketing by Norlet, they don't say this anywhere. They don't make it clear that this is just a pilot test for a technology that doesn't really make sense on that scale and that you would only use to later scale it up. Also, I'm not convinced because Norlet pointed me to another project where the same Norwegian Public Road Administration that funded the Hydra will fund a hydrogen-based ferry, and this is a route in northern Norway which connects the Lofoten Islands to the Norwegian mainland. The ferry operator there actually decided that they will use compressed hydrogen, which is in line with pretty much all the other projects where companies are looking into hydrogen-based shipping. Even if you argue that you need hydrogen for these medium distance routes, pretty much everyone is betting on compressed hydrogen and not liquefied hydrogen. If you enjoyed this video, of course, I would appreciate if you share it with other people. I'm also writing a newsletter where I'm covering topics like this, and I have recently covered this ferry in an article. You can find a link to that in the description.